Let's say one market sold 1,293 apples today, while another market sold 2,614. How many were sold in total? We definitely don't want to count all those apples, or we will be here all night. Instead, we can calculate the sum. So how can we do this exactly? Well, if we are using a pen and paper, the convention we have come up with is to place one number over the other, with a plus symbol and a line below. This signifies that we are adding the two numbers together, and the sum will be listed below this line. We must make sure that the numbers are lined up in such a way that the place values are in perfect correspondence. The units place goes with the units place, the tens with the tens, and so forth. Now the math is very easy because we just add two digits together at a time, starting with the units place. 3 plus 4 is 7, so we put a 7 here. With the tens place, it's a little trickier because 9 plus 1 is 10, and we can't put 10 here as we want a single digit. So instead, we must realize that we can put a 0 if we then increase the hundreds place by 1, signified by adding a 1 on top. This is called carrying the 1, and it works because 10 tens are the same as 100. We do this anytime we go over the capacity of a certain place to report value. So in the sum, we have a 0 for the tens place, and we move on to the hundreds place. The 1 that we carried, plus 2 plus 6, gives us 9 for the hundreds place, and then 1 plus 2 is 3. 3,907 apples were sold today between the two markets. This works the same way for subtraction. Let's say one market vendor started with 473 apples and sold 286. How many does that vendor have left? Let's arrange these numbers just as we did for addition, making sure to put the larger number on top. Now, starting with the units place, we have 3 minus 6. That's not going to work, so what if we borrow one of the tens from the tens place? If we cross out this 7 and put a 6 instead, we've borrowed 10 units that we can give to the units place. That means we can now do 13 minus 6, which is 7. Now, in the tens place, we have 6 minus 8. Again, this won't work, but if we borrow one of the hundreds from the hundreds place, 400 becomes 300, and we've borrowed 10 tens that we can use for the tens place. This means it's like we have 16 tens minus 8 tens. That gives us 8 for the tens place. Lastly, 3 minus 2 is 1. The vendor has 187 apples left to sell tomorrow. 14 over 11, with the places lined up, and we start by multiplying all the digits in the top number by the rightmost digit in the bottom number. 4 times 1 is 4, so we put a 4 in the units place. Then 1 times 1 is 1, but this 1 represents 10, so we get a 1 in the tens place. Now we are going to multiply all the digits in the top number by the next digit to the left in the bottom number. Because this is the tens place and not the units place, we place a 0 in the next row down for the units place, so that we can begin writing numbers in the tens place right away. Again, 4 times 1 is 4, but the 1 represents 10, so we are really getting 40, which is why the 4 goes in the tens place. Then 1 times 1 is 1, but both of these 1s represent 10, so we are really getting 100, which is why the 1 goes in the hundreds place. We add these two rows together, and we get 154. This is one way to multiply these numbers together, and we should know how to use this algorithm. But there is a much faster and easier way to do this, provided that we understand the distributive property. Let's split one of these numbers up into a sum that contains numbers that are a little rounder and easier to multiply. Maybe we can split 11 up into 10 and 1. Now, instead of 14 times 11, we have 14 times 10 plus 1. The distributive property tells us that this is the same as 14 times 10 plus 14 times 1, and these products are easy to get in our heads. When multiplying by 10, we just add a 0, so 140, and multiplying by 1 means the number stays the same, so we have 140 plus 14, or 154. Really, these two methods are doing exactly the same thing. It's just that one follows a rigid algorithm, while the other involves a little more creativity, as we have to look at the numbers and develop a strategy as to how we might restate these numbers to make things easier for ourselves. Let's try another one, 425 times 12. Once again, we certainly can follow the rigid algorithm. We put the larger number on top. 5 times 2 is 10, so we put a 0 and carry the 1. 2 times 2 is 4, plus the 1 gives us 5. And 4 times 2 is 8. Now we are done with the 2 in 12, so let's do the 1. Remember, we place a 0 in the units place here, since we are multiplying through the tens place. 5 times 1 is 5, 2 times 1 is 2, and 4 times 1 is 4. Now we just add these together. A 0 here, 5 and 5 is 10, so put a 0 and carry the 1. 8 and 2 plus the 1 is 11, so put a 1 and carry the 1. And 4 plus 1 is 5. 5,100 is our answer. If you like using pen and paper and are very diligent, there is no problem with this approach. But it opens up a lot of opportunities for error, so you may prefer the simpler approach using the distributive property. Instead of 425 times 12, let's do 425 times 10 plus 2. When multiplying by 10, we just add a 0, so that's 4,250. Then we multiply by 2. 400 times 2 is 800, and 25 times 2 is 50, so that's 850. Add them together, and we get our answer. Let's take a moment to notice that these numbers are the same as the ones we added together when using the other approach. That's because they are essentially the same approach. When we multiply through the units place, we are multiplying by 2. When we multiply through the tens place, we are multiplying by 10. But while the first method requires many small computations, the second method requires comparatively fewer. Still, through practice, you may find your own method that works for you, and as long as you